Hey crew, um, this is Mrs. Mahalik. It's Sunday night, and so this is for class on Monday. I just wanted to go over a couple things. These are missing assignments right here. So this is really, really critical because the eCyber Mission people need this. So um, I know some of you are absent, but if you have finished, it would be awesome if you posted on Google Classroom under today's video that you finished it, just so that I know. So this is really, really, really important, and it's probably what you need to take care of before you do your classwork today. Okay. Also, this is just for my sixth period class, but these assignments haven't been uploaded yet. And so you can also upload them onto today. Um, so I'll create an assignment. Maybe I'll just title it missing work or something. And you guys can just post those missing assignments so that I can get them in progress book because grades are due. So that would be fabulous. So what we're going to do is go ahead and pull out your packets onto page P and Q. So go ahead and pull out your packets on page P and Q. I didn't see anybody having uploaded this yet. So I'm not quite sure because you should have been able to finish it in class, but hopefully tomorrow some will get uploaded before class period. So if you go ahead and pull that out, sorry. I have the answers for you right here. So this should have been fairly easy for you. It should not have taken you a huge amount of time. But I really like that this kind of forces you to sit down and label things because we're just not very good at that. And it makes you write down your given variables. And I think for a lot of you, that's really, really helpful because it makes you stop and slow down and look at the formula. So let me get this out of the room. So this one, I think we did in class with some of you, but I got 3,000. So we had a mass and an acceleration. So 1,000 times 3. The next one, we had a force and a mass. And if you looked at the equation over here, we have acceleration equals force over mass. So 250 divided by 70 is 3.57 meters per second forward. This is a vector. Force and acceleration. So force equals mass times acceleration. And so then I had to get x by itself. So I divided and I got 833.33 kilograms. How much acceleration is given to this object? So we had a force and a mass. So it's set up the same way as this one. Or you could use this formula. It wouldn't have mattered either way. You should get the same answer. Oh, sorry, 0.0167 meters per second squared. And then last one, we had a force and an acceleration. So 6,000 equals 2 times x, and divided both sides by 2 to get 3,000. So what you're going to do today is more of the same. And we all know that practice makes perfect with math. So it's not difficult math, but you need to be practicing it because we all know when we don't practice it that when it comes to test time, you end up being sad, sad, sad. So if you flip in your packet to the next page, which is R and S, this is what we're going to work on today. So at the top of R, there's like a scenario and then A through E. We're not going to do that today because we're going to do that when I come back. We're going to kind of talk about how that works. But this should keep you busy for today. 8 and 9. 8 should be fairly easy. You have a force and you have a mass. So then you're going to put in acceleration. Please do not forget to put in units. And then 9 is more of the same. You're given the two variables. You don't have to sort anything out, and you just have to calculate the empty blank. So don't really care if you're showing your work so much in here because it already tells you what each of them is. For page S, 10 through 17, and yes, I do want you to do 17, the challenge question. You have to use acceleration formula. But I do want you to be doing force equals mass equals acceleration equals, and then label them and then show your work and circle your answer. So don't forget, force is going to be measured in a unit of newtons. Mass is going to be measured in kilograms. Acceleration is going to be measured in meters per second. So this is what you're going to work on today. Mrs. Prohaska, when most of them are done, I'm going to post a video here that is not, why can't, a crash course video. It's a little slower. And, but it's also on Newton's forces of motion, and then you can let them watch that and take notes. Other fun fact, sixth period, I'm really sorry about Friday. I thought that I was going to be feeling well enough to like wake up and get a special video recorded for you, but I didn't. I wasn't feeling well enough. So we kind of skipped Newton's first law of motion, and don't forget, or don't worry, I haven't forgotten that we skipped it. And so we are going to go back and do Newton's first law of motion when I come back. But for now, we're just going to kind of plot on forward with fifth period. And then when I get back, we're going to jump back and do Newton's first laws of motion because it's really important. So tomorrow's, please upload this as an assignment. Most of you have been doing a nice job. Make sure you write your name on it. So I would write Mrs. Mahalik. Upload it into Google Classroom, and then I'll enter it in as a grade for you. So, but I would anticipate that this probably will take most of you about 20 minutes, and then the video that I have selected is about 20, 25 minutes. And it's Bill Nye. So, like, what's cooler than Bill Nye, to be perfectly honest? I love him. So, hopefully, you guys are having a good day. And it's Monday. So, I should see you hopefully later on this week. All right, if you have any questions, make sure that you're posting it in Google Classroom so that I can make sure that I'm answering your questions. Okay? Hopefully, you guys have a good day. Bye.